In my last video of determinants, class 12 and onwards, the cofactors of a determinant and one of its important properties, and that property was verified by taking a simple example. Now we discuss property number 2 of cofactors of a determinant. Here you see property number 2 states that algebraic sum of products of the elements of any row or column with the cofactors of corresponding elements of any other row. Property 1 was of the same row or column. Here any other row or column is equal to 0. That is, if delta equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 be a determinant of third order, then according to the statement of this property, let we consider the elements of first row and cofactors of any other row, say second row, and we consider the cofactors of corresponding elements of second row. Then, according to statement of this property, we show that A11 cofactor of A21, that is A21, capital A21. Cofactor means in capital letter when there are given no numerical figures, plus A12, A22 plus A13, A23. The second A is capital, that is cofactor of the element stated here. This equal to A11, A31 plus A12, A32 plus A13, A33. You see here, equal to, let me now consider the elements of second row and the cofactors of corresponding elements of at first row, then third row. Equal to A21, A11 plus A22, A12 plus A23, A13 capital, equal to A21, A31 plus A22, A32 plus A23, A33. You see here, equal to A31, A11 plus A32 elements of third row, A32, A12 plus A33, A13 equal to A31, A21 plus A32, A22 plus A33, A23 equal to 0. All the expressions will give you its numerical value 0. This is the property 2 of cofactors of a determinant. We now verify this property by taking a very simple example. Here we verify this. To do this, let us consider a very simple example. delta equal to 1, 0, minus 3, 5, 7, 0, 3, 2, 5. Say, whatever may be the numerical values. Now, let me consider the elements of first row. Consider the elements of first row. You may take elements of second row also. One may take elements of third row also. But when you consider the elements of a row, then you never consider for this property the cofactors of the corresponding elements of the same row or column. Here, let me consider the elements of first row and cofactors of the elements of second row. And we multiply them and add them and we see what happens. 1 into cofactor of 5 plus 0 into cofactor of 7 plus, write it first, minus 3 into cofactor of 0 equal to 1 into, now you see cofactor of 5. Cofactor of 5 minus 1 whole to the power number of row it belongs to plus number of column it belongs to. In the second row it belongs to and first column, so minus 1 whole to the power 2 plus 1. Second row, first column, out. 0 plus 6 plus 0 into cofactor of 7, so it will be minus 1 whole to the power belongs to second row and second column, second row, second column. So it will be 5 minus a plus 9. Okay. Minus, this is minus 3 into minus 1 whole to the power second row and third column, second row and third column, 2 minus 0. Equal to minus 1 whole to the power 3, that means minus, here is 6, so you will get minus 6. This is 0, so it is obviously 0. This is minus, because minus 1 whole to the power odd number, so it is minus, minus 1 is a plus. 3 into 2, that means 6. Equal to, you see here, 0. So, for this problem, this is chosen at random and I established the property by using this example. Now, let one may consider, because I have written in the bracket or column. So, let you take the elements of first column. See what happens? 1 into, say, you consider the elements of third column and cofactors of the corresponding elements and take their product and sum. So you write 1 into cofactor of -3 plus 5 into cofactor of 0 plus 3 into cofactor of 5. We see what happens. This is equal to 1 into, so it may be omitted, cofactor of -3 -1 whole to the power, the element -3 belongs to first row, so this is 1 plus third column, omit 10 minus 21, 10 minus 21, okay, plus 5 into cofactor of 0, -1 whole to the power, 0 belongs to second row and third column. Second row and third column into, omit them, 2 minus 0 plus 3 into cofactor of 5, so -1 whole to the power, 5 belongs to third row and third column, so third row and third column, 7 minus 0. Okay, now you see what happens. This is -11 and -1 whole to the power 4, so it is plus. So ultimately it will be equal to -11. This is 2 plus 3, odd, -1 whole to the power odd, minus, so minus 5 into 2, that means 10. This is -1 whole to the power 3 plus 3, even number, so it will be plus, therefore this will be 3 into 7, and this gives you -21 plus 21 equal to 0. So the statement valid for rows as well as columns also, and I have verified the statement by considering this very simple problem. You may verify the statement by taking another problem by your choice, and you see this is true for every numerical problem. Later we see this will be true whether the elements are numerical or not. Now we discuss about adjoint determinant. Adjoint determinant. Adjoint or adjugate, may also called adjugate. I say it adjoint determinant. In short, later we will write ADJ, adjoint. If delta be the determinant, then adjoint determinant ADJ delta. adjoint delta. What is adjoint determinant? At first we define what is adjoint determinant. The determinant formed by the cofactors of corresponding elements of the given determinant. Of the given determinant is called adjoint determinant. The determinant formed by the cofactors of corresponding elements of the given determinant is called adjoint determinant of the given determinant. May write or may not write. So, here let delta equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Be a determinant of third order. You write this first. According to definition, adjoint determinant of this determinant is the determinant. Adjoint determinant of this determinant is the determinant whose elements are the cofactors of the corresponding elements, whose elements are cofactors of the corresponding elements. Then adjoint determinant of delta equal to, what is its adjoint? A11 by notation, and the value we have already discussed in my earlier video. So you at first obtain its adjoint and put here. Omit the original element given in the determinant. You omit this and replace this by its adjoint. You omit this, replace this by its adjoint. Omit this and likewise. So, the elements of the given determinant when be replaced by their cofactors. The elements of the given determinant when be replaced by their cofactors, we will get another determinant. That determinant is nothing but adjoint of this given determinant. So this is adjoint determinant of delta, and it is usually denoted by delta dash. So delta dash equal to this. So if delta be a determinant, then what do you mean by the symbol delta dash? Delta dash is nothing but adjoint determinant of the given determinant delta. What is adjoint determinant? Adjoint determinant is the determinant whose elements are the cofactors of corresponding elements of the given determinant. So this is the adjoint determinant. Okay? Now, we have proved a very important property of adjoint determinant of a determinant. The property is that if delta not equal to 0 be a determinant whose adjoint is delta dash, then delta dash समान equal to delta square. Most important property. In future, we will discuss several problems by using this property. All those problems appears typical in nature, but they are very simple if we understand that comes out by using this property. So, if delta not equal to 0 be a determinant whose adjoint is delta dash, then delta dash equal to delta square. So, we now prove this. Prove. Let delta equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, and delta dash. Already stated the adjoint is delta dash equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. These are given and also given that its numerical value is not 0. We have to establish delta dash equal to delta square. To do this, we have delta into delta dash equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 multiplied by A11, A12, A13, A21, A22, A23, A31, A32, A33. Now we multiply by the rule of multiplication of two determinants. We have learned earlier A11, 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 A11 plus A12, A12 plus A13, A13. Second one, A11, A21 plus A12, A22 plus A13, A23. This is the second element, and the third element will be, here the space is very small, so I write it here, A11, A31 plus A12, A32 plus A13, A33. Complete the determinant sign. Now go to second row. A21, A11, A21, A11, A22, A12 plus A23, A13, A21, 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 A11, A22, A12, अच्छा, A21, A21 plus A22, A22 plus A23, A23. This is the second element of second row. Space is small, I write it here. A11, A21, A21, A31 plus A22, A32, you follow my words also, plus A23, A33. So this is the third element of second row. Now we proceed for third row. A31, A11, A31, A11 plus A32, A12 plus A33, A13. This is the first element of third row. Next one, A31, A21 plus A32, A22 plus A33, A23. This is the second element of third row. Now we write the third element of third row. A31, A31 plus A32, A32 plus A33, A33. Okay. Now you see that this expression means the elements of first row were considered, their corresponding cofactors were determined, the product obtained and their sum, that is the property 1 of cofactors of a determinant. This is property 1 of cofactors of a determinant. If each element of any row or column be multiplied with the cofactors of their corresponding elements and obtain their sum, that will give you the value of the determinant delta itself. Property number 2, this is the element of first row. These are the elements of first row. And these are the cofactors of corresponding elements of other row, that means second row. We have taken their product and algebraic sum. By property, value of this must be 0. And you see, in similar fashion, the value of this must also be equal to 0. So ultimately, you get this equal to, this is delta, this is 0 and this is 0. This delta comes from property number 1 and these two property number 2. You just learned here. This property number 2, this property number 1, this property number 2, this property number 2, this property number 2 and this property number 1. And if you expand this, delta omit this row and this column, and you will get delta square. And two other elements are 0 since, therefore other expressions will be 0, and this will be equal to give you delta cube. This equal to delta cube. So finally you see that delta into delta dash equal to delta cube. Okay. Therefore, delta dash equal to delta cube by delta equal to delta square, provided delta not equal to 0. So this is the main property of adjoint of a determinant, most important property. Let us take a very simple problem. Or say it 5. Now, I have told to obtain the cofactors of all the elements for the elements of first row. Cofactor of ato, cofactor of this, all are calculated individually, and that was a long process. But delta dash, to obtain delta dash is nothing but these elements will be replaced by their corresponding cofactors. So here we delta dash, here we use technically form, you do it technically, very short form. Since this is of order 3, you write 1 minus here, 1 minus here, 1 minus here, and 1 minus here. Thus like diamond. So, since it is of order 3, if it is of order 2, then you write minus here and minus here. One element will be here, one here for the first row, one here and one here for the second row. Since it is of third order determinant, so you write at first, to avoid any difficulties, any mistake, you write first minus, 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 minus. Okay? Now, for 2, 5 minus 6, you write here 5 minus 6. For 0, omit this, 25 minus 0. For 7, 10 minus 0. For 5, omit this. 0 minus 14. For 1, omit this. 10 minus 0. So you write straightforward 10. 10 minus 0. For 3, omit this, 4 minus 0, so 4. For 0, omit this, 0 minus 7, so it will be minus 7. For 2, omit this, 6 minus 35, so you write here 6 minus 35. For 5, omit this, 2 minus 0, you write it 2. So, this is equal to minus 1, minus 25, 10, 14, 10, minus 4, minus 7, minus 29, so it will be 29 and it will be 2. Okay, so this is the adjoint determinant of this determinant. Keep it. Now, here we simplify it to find its numerical value is equal to 2 into 5 minus 6, that means minus 1, and 0 here, so that will be 0, plus 7, omit this, 10 minus 0, so 10 equal to 70 minus 2, that means 68. So, value of delta is 68. 68. Now, delta dash, put delta dash, minus 1, minus 25, 10, 14, 10, minus 4, minus 7, 29, 2. We multiply these two. We multiply these two equal to minus 2, this is 0, plus 70, so it will be 72. 28, 0, minus 28. 28, 0, minus 28. So it is 0. Minus 14, 0, plus 14. So this is also 0. We are very lucky, I think. Now, minus 5, minus 25, minus 30, plus 30. So this is another 0. 70, plus 10, 80, minus 12. 80 minus 12, 80 minus 12, so it will be 68, minus 35, plus 29 plus 6 minus 35 plus 29 plus 6. So it is 0. Zero minus 50 plus 50. Beautiful. 0. 0, 20 minus 20. So this is another 0. 0, 58 plus 10. That means 68. There is some mistake, this number. Check it. The cofactor 10. You check the calculation. Minus 2, 0 plus 70. Oh, that was a mistake. That was a mistake. Minus 2 plus 0 plus 70. Minus 2. So that is 68. You check the calculation. That was a mistake. Minus 2 plus 0 plus 70. So this will be minus 68, only 68. And when you calculate it, it will give you 68 cube. So this is delta into delta dash equal to. But what is the value of delta? We write here, it is 68. Therefore, 68 delta dash equal to 68 cube. Delta dash equal to 68 square. So, the adjoint determinant delta dash equal to delta square. The numeric value of delta was 68 and delta dash equal to 68 square. Thus, the statement proof all are along with this problem is verified. I am very sorry, there was a mistake, minus 2 plus 70. I have added them together, but it will be subtracted from 70 and it will make 68. Thank you all of you. Feel my video will be helpful for you. I will do various types of problems in my next video. If you feel that you are helpful with my videos for determinant, then please put a like and share for your other friends, for which they will also be take some advantage to know about determinants. Thank you all. Jamula.